Hello and welcome to 9.2. So this section is on quadratic inequalities in one variable. And our next section will be quadratic inequalities in two variables. So just kind of drawing the distinction between this section and the next section. And I find this one to be one of the ones that's a little bit tougher. It kind of introduces a new concept of sign analysis. But at the same time, it gives a few different methods for analyzing quadratics in one variable. So I think the best way to start is to start by looking at a few examples here. So part A is on solving quadratic inequalities when given a graph. So here we have a graph of the function y equals x squared minus 3x minus 4. So that's what we're seeing down here in the picture. So notice that's actually an equation. So when you graph that function, it looks like a parabola. Okay, now what we want to do is consider this inequality where we have that expression is greater than 0, and then where we have that expression is less than 0. So we're going to consider both of those. So the first thing we need to do is identify the zeros for this function. In other words, the x-intercepts. I think it's fairly obvious from looking at this graph that we have x-intercepts at -1 and at 4. You could also calculate by setting y equals to 0, but we're going to go with this just to speed it up a little bit. Now the x-axis is divided into 3 sections by the parabola. So what are the 3 sections? So see my dots here? They have made boundaries between 3 different sections. We've got this section on the left, the section in the middle, and then we've got the section to the right of that dot. So section 1 would be x values that are less than -1. Then we have the section from -1 to 4, so x values between -1 and 4. Then we have x values that are greater than 4. So there are our 3 regions. Part B is asking us to identify the x values for which it is greater than 0. In other words, where's our parabola greater than 0 or above the x-axis? So I'm going to use my highlighter here to help illustrate that. So where is it going to be greater than 0? It's going to be here, we're above 0, and here we're above 0. If you think of this line as being like sea level, it's kind of like saying being greater than 0 is like being above sea level. So that would have been zone 1 and zone 3. So we're going to write those as our x values for which it is greater than 0. So that was true when x was less than -1, comma, and x was greater than 4. And then with my highlighter here, the region where we were less than 0 was when we were below sea level, which was this region here. And so that would have been the same as this. And so that is our, domain for when we have the function having a value less than 0. So that would be from -1 to 4. Okay, so this is when we had, in other words, a positive y values or positive graph, and this is when we had a negative graph. Let's look at another example. It skips to number 3 for some reason. That's a typo, but doesn't really matter. Okay, let's go and take a look at this graph. So it's already graphed for us. So there's that function. You can tell it's a function. It's got the equal sign. Now we want to say, hey, which zones is it greater than 0, less than or equal to 0, less than 0, or greater than or equal to 0? So I'm going to keep my above parts. I'll do those in yellow again. So I know that this is, I'm still in green. Let's try that again. So this is where it's positive. This is where it's positive. So positive means greater than 0. So that would include that one as well as this one. The below portion would be the less than 0. So those are the ones that match each of those. Now we just have to kind of write the domains out algebraically for those sections. So when were we yellow? Well, we were yellow, and it's asking for greater than 0, but not equal to. So we're going to say that's true if x was less than -2, so if we were going this way on the x-axis, or if x was greater than 1. Now that's going to be basically the same answer for D, except we just have to include the equal sign underneath our inequality. So x is less than or equal to -2, or x is greater than or equal to 1. So just because of that little difference here, that's the only difference when we write out our solution there. Okay, for the green zone, that was true when x was between -2 and 1. So this would be true if x was between -2 and 1, but notice I've put the less than or equal signs there. And on this one, I'm just going to put the less than signs. Okay, part B, solving a quadratic inequality in one variable using sign analysis. Sign analysis is something that you'll use in future math classes to analyze different kinds of functions. And so it's a good time to practice it. And I don't think it's something that you've seen before. So this is one method. As you can see on the next page here, another method is using roots and test points. So part A was good if you have a graph, okay? But if we don't have a graph, then we have to either use sign analysis or roots and test points to come up with our solutions. So there are some hints over to the side here. Let's just read them quickly. So first, we're going to bring all terms to one side of the inequality. In other words, set one side to 0, which we're used to doing anyway. This one already has that done. Okay, then we're going to factor completely. Then we're going to perform a sign analysis on all the factors. This will involve finding the zeros, and then we will describe with an inequality the values of x that satisfy this version. So what we're essentially doing when we're solving these is trying to come up with the x values that make this true. That's what we were writing down here as well. We were coming up with the x values that make this statement true, or this statement true, or this statement true, or this statement true. So these are our solutions. They are representing all of the x values that make those green and yellow statements true. So how do we do that when we don't have the graph? Okay, so we've already got step 1 done. It's already set to 0. Now we're going to factor. So a little bit more practice with our factoring skills. So this ends up becoming x minus 8 and x minus 2. So now we've factored. Now we're going to perform a sign analysis. So this is a new thing for you guys. You have not seen this yet. And a sign analysis is, once you get the hang of it, it's a little bit weird at first, but once you get the hang of it, it's pretty neat, a neat way of analyzing your function. So what I'm going to do is draw 3 lines here. One to represent the x minus 8 function, one to represent the x minus 2 function, and then one to represent the 2 functions multiplied together. And so it's like analyzing 3 little number lines. So my first line gets labeled with the x minus 8 factor, the second one with the x minus 2 factor, and then the third one is going to be the result of multiplying the other 2 lines together. So you'll see what I mean in a minute. Well, we need to know where our x-intercepts are. And so our x-intercepts, or zeros, are at 8 and 2. And you can get that by doing your little chart here. We get the solutions of 8 and 2. So I'm going to mark on all of my lines the 2 and the 8, and that's it. I'm not going to mark any other numbers on there. Those are the only ones we're concerned with. Basically, that is where our x-intercepts would be if we graphed this. So those are important points. Just like in the last examples, the x-intercepts were what split our solution regions up. That's why we are doing the same thing here with x-intercepts. So the question is, on this number line, if I have x minus 8, what is that going to do in terms of the signs if I put a different value of x in here? So for example, if I put 8 in here, 8 minus 8 would give me 0. So if I plugged in an 8, I would actually get an answer of 0. So I'm going to mark a 0 on there. If I plug in anything to the right of 8, like 9 or 10, I would get a positive value. So it could be positive 1, positive 2, and then so on and so forth. If I plug in anything less than 8, like 7 minus 8 would give me a negative. So anything to the left of 8 would give me a negative. Anything to the right of 8 would give me a positive. And if I put 8 in itself, it would give me a 0. So it's a sign analysis because we're analyzing what signs we would get in terms of positive or negative signs, or we have to mark our zeros in there as well. Now for the 2, the 0 would be when I put 2 in. So 2 minus 2 is 0. So that's where the 0 would be. Anything to the left of 2 would be negative. Any values on the number line to the right of 2 would make this factor positive. So if I put in a 3, 3 minus 2 is 1, that would be positive. If I put in an 8, 8 minus 2 is 6, that would be positive. Now what I'm going to do is multiply my number lines. So a negative times a negative would give me what here? So negative times a negative, that would give me a positive. So why am I multiplying them? Because this number line represented solutions for the x minus 8, or the signs. This one represented the signs for x minus 2. This one represents the signs for multiplying the two of them together. Okay, now what if I go ahead and multiply these ones? So positive times a negative. Well, a positive times a negative is going to give me a negative. I'm not going to highlight this one, but you can imagine a positive times a positive gives me a positive. 0 times a positive would give me a 0. 0 times anything would give me a 0. So if we interpret our answers here, what we are learning is that our graph would have zeros at 2 and 8. In other words, those would be the two x-intercepts, and it would be positive to the left of 2, positive to the right of 8, and negative in between. So this question was asking us, when is it going to be less than or equal to 0? In other words, negative or 0. So it would be 0 here, it would be negative here, and it would be 0 here. So we have to include that as our solution. So the solution for this one is all x values as long as x is in between 2 and 8. And that includes the 2 and the 8. So without graphing, we can tell where we have negatives or zeros. Now, if it helps you to see the graph, this is actually enough information, if we just want to do a real quick sketch of a graph, that at 2 and 8, that's where our x-intercepts would be on this function. And this function is represented by this bottom row, and that would be positive this way and underneath this way, or negative that way. Horrible sketch with my pen there, but you kind of get the idea of what this is representing if you look at it in Desmos. And in fact, I'm going to just move over quickly to Desmos. I have it graphed here so you can see it. So there's the 2 and there's the 8, and it was below, in between, and above on the sides. Okay, so back to our examples here. Let's take a look at another one. Okay, so we probably don't like the fact that this one has a negative in front of the quadratic. So we're going to multiply or divide, either way, the entire thing by -1. So that means both sides by -1. That's going to give me x squared minus x minus 12. But remember, I divided by negative, so I have to switch the direction. So I'm now looking at x squared minus x minus 12 is greater than 0. I'm going to factor that, and I get x minus 4. X plus 3, and that's greater than or equal to 0. My zeros are going to be at 4 and -3. Okay, so here come my 3 number lines. 1, 2, 3. So the first one is going to be x minus 4. This one's going to be x plus 3. And this one's going to be x minus 4 times x plus 3, the entire function. Okay, so I need to make my markings at -3 and 4. So the x minus 4 factor, while my 0 would be at 4, anything to the right of that greater than 4 would be positive, anything to the left of that negative. For my x plus 3 at -3, I would be 0, anything to the left of that negative, anything to the right of that positive. A negative times a negative is a positive. Anything times 0 is 0. I'll mark those in. Negative times a positive is negative. A positive times a positive is positive. So this question was asking for, actually I'm going to go down to the one that I kind of modified it here. It's looking for when we are greater than 0. because this is the one that I actually factored and analyzed. And so my solution regions would be anywhere that is greater than 0. So positive, positive, and I don't want to include the zeros because it said greater than 0, not greater than or equal to 0. So I want this part of the number line to be my answer, and I want this part of the number line to be my answer. So the final solution for this one is x values less than -3 or x values greater than 4. And you'll often see in the answer key at the back, they may also say x belongs to the set of all real numbers. I didn't say that earlier, and maybe I should have. That's kind of dependent on the textbook or whatever you're checking on. Can't remember what ours does. Okay, let's take a look at the next one, number 3. So I want to move the 12 over because I want to be able to factor this as a trinomial. Okay, it doesn't have a GCF, so I'm going to have to do a little bit of guess and test here to figure out how to factor it. This one factors as 2x plus 3 and x minus 4. That gives me my zeros of -3 over 2 and 4. So now I go ahead and draw my 3 number lines, one for each factor and one for the product of the factors. So this one would be 2x plus 3, this one would be x minus 4, and this one would be 2x plus 3 times x minus 4. And my x-intercepts or zeros are at -3 over 2 and 4. Okay, I'll write those in everywhere. So I would have a 0 right here, -3 over 2. Anything to the left of that is always negative. Anything to the right, positive. Here my 0 would be at -4. Anything to the left of that, negative. Anything to the right of that, positive. Negative times a negative is a positive. Positive times a negative is a negative. Positive times a positive is a positive. And I have 0 and 0. So this question was asking me for when are we greater than 0? So we're greater than 0 when we're positive. So there, but not including that 0, and there, but not including that 0. So our solution is x has to be less than -3 over 2, or x has to be greater than 4 and belongs to the set of all real numbers. So this is our solution. Maybe I should be circling that to make it more obvious. Okay, 2 more, and then I'm going to show you a different method. Okay, so again, we're going to move the -49 over. So on each example, I'm trying to illustrate something a little bit different. I think what's interesting about this one is we get the same factor twice. So that's a little bit different, meaning that our x-intercept is only at 7. We only have one x-intercept this time. So that changes things a little bit. So I'm going to go ahead and draw my 3 lines. So I got the 2 factors and then the product of the factors. And so one of those is x minus 7. The next one is also x minus 7. And then I have x minus 7 all squared. What's interesting here is that I only am going to have one tick mark, and it's going to be at 7. And I'm going to have my 0 at 7 all the way down. Anything to the left of 0, negative. Anything to the right, positive. Negative times a negative is a positive. Positive times a positive is a positive. So this is telling us that this is, if we were to graph the equation of this, then we would get a parabola that has an x-intercept of 7 and opens upward. Everything was looking positive. So this question is particularly asking us for solutions where we are greater than or equal to 0. So we're looking for anything here where we're greater than 0 or 0. So all of this is included. So x could be anything. There's no restrictions on it. X could be anything. Oh, I'm sorry. I lied. It was asking for less than or equal to 0, not positives. It wanted negatives. Mistake. Less than means negative, less than 0. So we don't have any place where it's negative, but we do have one spot where it's equal to 0, which is just on the 7. So instead of it being everything's an answer, the only answer actually is 7. Any other number would give us a positive value, and we want only answers that give us something negative or 0. Okay, looking at number 5, it's got a few stars just because it's a little bit outside the box, a little bit different, but let's try it out. So this time we're noticing right away we have a cube, which is a little bit funny. I'm going to move my 4x over and set the right side to 0. I do have a GCF, but then I'm able to factor that as a difference of squares. So what this tells me is I now need 4 lines to analyze something like this. I have 3 factors and then the product of all the factors. So it's not really that much tougher. It's just a little bit different. So I've got my x factor, I've got x plus 2, I've got x minus 2, and then I've got the whole thing. So what are my important points that I'm going to make tick marks for? Well, my zeros are, and I should have done this up here on this step, I have 0, -2, and 2. So those are the spots I need to mark. So there's my -2. 0 is important to me. And +2. The strategy is entirely the same as what we've done in all the previous questions. We're just going to be multiplying 3 signs together this time. So my zeros would be here, here, and here. And anything to the left of those zeros is negative, anything to the right is positive. We just have kind of 4 zones that we're looking at. So negative, 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 positive. And a negative times a negative times a negative is negative. A negative times a positive times a negative is positive. A positive times a positive times a negative is negative. 3 positives multiplied together is positive. So here's our final row. We've got a negative zone, then 0, then a positive zone, then 0, negative zone, 0, positive zone. And it is asking us for less than or equal to 0. So negative or 0. So negative zones work and zeros work. Negative zones work and zeros work. So those are my solution regions. I can't have anything where it's positive. So to write this out as a final answer would be, this is true when x is less than or equal to -2, or when x is between 0 and 2, inclusive. And I will put back on the all real numbers tag. Why didn't I have to say in the last question all real numbers? Because there was only one solution. But when you're describing more than one, sometimes we'll put that on there just to show it's not just integers, it's not just whole numbers, it's all real numbers, fractions, decimals, and everything in between. Okay, so that's one method. That's called sign analysis, because we figure out all the signs and then we analyze the signs by multiplying them together. In the next section, part C, we're going to use a method called roots and test points. And it's kind of similar, but a little bit different. So roots are still basically zeros. So we're still going to do that step of finding that out, but then we're just going to test points similarly to what we did in our last section and see if we get true or false values. Okay, so our first example here, initially pretend it's an equation to find its roots. So you would factor this, x minus 6, x plus 2, and that would give us our roots of 6 and -2. Okay, so if you think about 6 and -2 on a number line, -2 would be there and 6 would be to the right of it. So we've got 3 sections of our number line. We've got the x being less than or equal to -2. And the reason I'm putting the equal bar underneath is because it was part of my question. So when it's part of my question, I'm going to include it in my intervals. If it wasn't there, I wouldn't put it here either. Then I've got my zone from -2 to 6. And then I've got my zone where we're greater than 6. Okay, so now we're going to choose a test point in each of those regions. So a test value would be something in this zone. Okay, and this zone, in fact, I'll highlight just to kind of show. So that zone is here. So our test point would be something in that region. So something less than -2, well, why not -3? Try to pick something easy, either a number that's not too crazy large or something with a 0 or a 10 are often easy. Now I'm going to substitute that value into my inequality here. So I'm going to put 3 in there and see if I get a true or false value. So 3 squared minus 4 sets of 3 minus, -3, not 3. Better put brackets around that. -3l squared minus 4 times -3 minus 12. Is that greater than or equal to 0? So that's the question. -3 squared is 9. -4 times -3 is plus 12. And I've still got my minus 12 is greater than or equal to 0. So here I'm getting 9 is greater than or equal to 0. And that is true. That's a yes. Okay, what if I pick something from this region? Oh, there we go. From this region. Okay, so the easiest thing to pick from that region, or easiest value to pick, would be 0. And if I substitute in 0, I get -12 is greater than or equal to 0. That's a false. So that's no, that is not true. Okay, now I want to check my next region, my third region, or interval. I'm calling them intervals, I'm calling them regions. Something greater than 6, and like I said, I like to use easy numbers, so I'm going to pick 10. So 10 squared minus 4 groups of 10 minus 12, is that greater than or equal to 0? So I get 100 minus 40 minus 12 is greater than or equal to 0. So I get 48 is greater than or equal to 0. And yes, that's true. So my final answer is where I got my yeses. I better highlight this just to be consistent. So there was my third region. So in other words, this was right, this was right, and this was not right. Okay, and so I'm going to write out my solution now, and I'll just write it above here. So this inequality was true when x was less than or equal to -2, or x was greater than or equal to 6 and belonged to the set of all real numbers. I would have got the same solution if I would have done that using the sign analysis method. This is just an alternate method. Ultimately, I don't really care which one you're more comfortable with, or you need to know both. They're both good to know, but ultimately they do the same thing. So if you're more comfortable with one than the other, that is probably fine too. I don't think it matters. Okay, so let's take a look at this next one. Of course, we want to try and factor this. Unfortunately, it's not factorable. So we are going to have to use the quadratic equation. So our b value is -7. So -7 plus or minus the square root of -7 squared minus 4 times 2 times -12 all over 2 times 2. So it gives me 7 plus or minus 49 plus 96 all over 4. Keep on working up here. So our x value is going to be equal to 7 plus or minus 49 plus 96 is 145. And that's over 4. And unfortunately, it just doesn't really get any better than that. So again, this splits into our two solutions. So we've got the 7 plus root 145 over 4, and then we've got the 7 minus root 145 over 4. And when we calculate these on our calculators, we get about -1.26 and about 4.76. Now, normally we don't take them into decimals, but the reason we want to do that right now is because we have to draw a number line and divide it up somewhat. And so we need to know approximately where those zeros are. So it's at approximately -1.26 and approximately 4.76. Okay, so, but really this value is 7 plus, sorry, I mixed these up when I wrote my answers. Have these in the wrong spots. Let's just fix that. So this one was the 4.76 and this one was the negative 1.26. So this one would have been labeled as, technically this point isn't negative 1.26, it's technically 7 minus root 145 over 4. And this one's technically 7 plus root 145 over 4. So to be ultimately correct, that's how we have to write it. The reason we are rounding to decimals is so when we pick test points, we know approximately where our test points are. Pretty hard to tell if you're using radicals. So our first interval is when we have x values less than 7 minus root 145 over 4. Then we have, when we go from the 7 minus root 145 over 4 to the higher end of 7 plus root 145 over 4. And then we have x values being greater than 7 plus root 145 over 4. So a test point. So a test point in this first region. So if I think about this first region, yellow, this is yellow, that means my test point has to come from the yellow region. My second interval, the middle, is this part, my test point has to come from the green area. The third interval, the blue part of my number line, that's where my test point has to come from. So that's why we needed the approximate decimals. So something that's less than minus negative 1.26 would be negative 2. Whoops, I wrote that in the wrong spot. It would be negative 2. For the middle region, I could choose a test point of 0, which is nice. And for the upper region, I have to choose something bigger than 4.76. So I'm going to choose 5. So those are going to be my substitutions. And I'm putting those back into this original inequality. Just trying to see if I get a true or false value. So negative 2 squared is 4. 4 times 2 is 8. Plus 14 minus 12 is less than 0. 22 minus 12, I get 10 is less than 0. Well, that's false. So that's no. So that's not part of my answer region. Let's check the 0. 2 times 0 squared minus 7 times 0 minus 12 is less than 0. Well, these both become 0. So I get negative 12 is less than 0. That's a yes. So here's part of my solution region. Let's just make sure. We're kind of assuming this is going to be a no, following patterns we've noticed before, but let's just test it out and make sure. So 2 times 5 squared minus 7 times 5 minus 12 is less than 0. 5 squared is 25 times 5 is 50. Minus 35 minus 12 is less than 0. That's 15 minus, so I get 3 is less than 0, and that's a no. So this is my answer region. So I have to, this is basically my answer right here that I've highlighted in green. I'm just going to rewrite it. Need a little bit more space to do that. So my solution is x values as long as x is between these two roots, which are kind of long to write. And x belongs to the set of all real numbers. So don't use your decimals. Be exact. The decimals are technically wrong. The roots are technically right because they're exact answers. There's one more of these to take a look at in this format, and then I think we're done this section. Yeah. Okay. So last one here. I feel like it's not quite as bad as the last one. What could be worse than that last one? Quadratic formula, roots that don't even simplify, fractions, we had it all. Okay, so we're going to start by moving the 10 over, setting one side equal to 0. Is this factorable? Please be factorable. Please be factorable. I can't think of any two numbers that multiply to make 10 but add up to make negative 4. Unfortunately, we will have to do the quadratic equation again. So here's our quadratic equation. Let's hope something at least maybe simplifies here. So our b value is negative 4. Make sure my root sign goes all the way across. So I get 4 is on the front plus or minus 16 plus 40 all over 2. The more you do these, of course, the less onerous it is. So I got root 56 over 2. Root 56 does simplify a little bit to be 2 root 14 over 2. So I can reduce a little bit here. So I get 2 plus or minus root 14. So not ideal. Again, I have 2 minus root 14 and 2 plus root 14, but at least it's not a fraction. So that's a little bit better. We're able to simplify it somewhat. When you punch these into your calculator, you get approximately negative 1.74 here and approximately 5.74 here. So one of my intervals is x being to the left of 2 minus root 14. Then there is x being in between 2 minus root 14 and 2 plus root 14. And I just have to scroll back up and see, oh, I need to put the equal sign on there too, not just the less than symbol, because that was part of my original question. So it needs to be part of this. So they should have those markings on them. My last one would be x values greater than or equal to 2 plus root 14. So the test points are going to be come up with using our decimals. So I can use a 0 here because 0 is in between those two values. I have to use something less than negative 1.74, so I'm going to choose negative 2. I have to choose something bigger than 5.74, so I'm going to choose 6. Now I'm going to scroll back up so I can see my original question. So x squared minus 4x is less than or equal to 10. So there's my substitution step. So I get 4 plus 8 is less than or equal to 10. So 12 is less than or equal to 10. That's a no. Okay, if I put 0 in just to make sure, I get 0 and 0. Is 0 less than or equal to 10? Yes. If I put 6 in, 36 minus 24 less than or equal to 10. I get 12 is less than or equal to 10. That's a no. Okay, so this is my solution region, which means this is basically my solution. I'm just going to write it out in final form. So my solution is any x values as long as x is between 2 minus root 14 and 2 plus root 14, and x belongs to the set of all real numbers. So just make sure little details like, is it just a less than sign or is it less than or equal to? You look back to your original question for that information. Oops, I thought I was on highlighter. But whatever you see here is the same kind of symbol you're going to see in your answer. Okay, that brings us to the end of 9.2. And so our next section will be talking about quadratics, but not just the x solutions as we were talking about here. So this is one variable with x solutions. We're going to be talking about our solutions on that coordinate plane again with x and y coordinates. All right, thanks for tuning in, and we will see you next time for 9.3.